Hey everyone. Today we'll be looking at a longest palindromic substring, and it's kind of difficult to wrap my head around this question. So I watched a couple of videos, and this the video from TechDose was really intuitive. Like I understood the explanation of the TechDose, whereas what Neetcode explained uh, wasn't that intuitive, and there is an mistake that someone pointed out in the comment section, but let's not talk about that. We can get straight into the code. So we want to identify we so let me get this in between, in middle. Okay, so it doesn't looks like it doesn't want to get in middle. So yeah, looks like we want to find out what is the palindrome, like the longest palindrome from this length, this string that has been given to us. um, but yeah, so the brute force approach, I didn't think about the brute force approach. I thought this problem can be solved with the help of sliding window, because it seemed like a sliding window problem. If we oh, sorry, control shift T. Okay, I'll show you why did I think that way. So if you see these problems, let me zoom it a little bit. Yeah, if you see these problems, longest substring without a repeating character, longest repeating character, all this question sounds a bit like sliding window. And in 1D we have this longest palindromic substring. So basically, yeah, this question I thought it can be solved with the sliding window, and I tried it, but I failed miserably. So here I am. I saw a couple of videos, and let's see what they have to say. So if we have to do a brute force, then what we have to do is we have to take every single character and compare it with every other character in the given string. So this will look like this, and then we'll go here, we'll go here, we'll go here and check if these guys are palindrome. So every guy we are checking if this is palindrome, if this is palindrome, if this is palindrome. So we have to traverse the um, so to check the palindrome it takes n, because if say let's say we take this string, so we have to traverse the uh, all the characters, so it will n. And in order to compare everything with each other like this, we'll be doing n square operations. So n into n square will be big of n cube, n cube operation, which is uh, not efficient at all. So let me okay, yeah. So there is a better way of doing this, using dynamic programming. So in dynamic programming, what they are doing is, let me just draw out this. So let me so after indexing this string, what they have to do is, um, they create a 2D matrix. So 0 1 2 3 4 5 6 7. So yeah, let's draw a 7, and 0 1 2 3 4 5 6 7. Okay, let's draw out this. Or 7, let's draw it like that. Okay, so we have our matrix with us. So what we got to do here is that we need to Um, so we know for that. I was reading through the editorial. So what they are saying is, okay, where was that? We all know that, yeah, we all know that all substring of length 1, let me zoom it a bit so it is visible to you guys. So we all know that all substring of length 1 are palindromes. Okay, from this we can check if each substring of length 3 is a palindrome using the above fact. We just need to check I-J pair where, okay, all that being said, we just need to we know that length, every character is a palindrome. So this matrix will basically help us to identify what all. So this is the start of any character, and this is end of any character. So 0 0 means we are pointing at this, 1 1 means we are pointing at this character, 2 2 and 2 means we are pointing at this character. So every character will be palindrome of itself, so we can mark it as true. Everything will be true. Okay, so once we do that, we need to also do it for the string which are of length 2, right? Because, okay, so what about even length? A substring of length 2 is a palindrome if both characters are equal. So yeah, for even length palindromes we need to check it with 2. So um, what we do is that is I and I plus 1, we need to check with that. So for 0 we'll check it with 1, 0 and 1, then 1 and 2, then 2 and 3, then 3 and 4, 4 and so on and so forth. We need to check that, right? um, yeah, so let's go here and check this out. Give me a second. Okay, yeah, so we need to do this. Okay, so we start from 0 and we check 0 and 1. Yeah, they both are equal. I'll use some different color for simplicity's sake. A, and so we are comparing first these two. So yeah, these two are equal, then we can mark it as true. Then we will check 1 and 2, they both are equal as well, and we'll mark it as true. Then 2 and 3, this is 2 and 3, we'll mark it as true. Then 3 and 4, they are different, so we mark it as false. Then 4 and 5, we'll mark it as true. Then 5 and 6, again false. Then 6 and 7, 6 and 7, you mark it as false, right? Oh, sorry, true, my bad. I guess this doesn't work here. Okay, yeah, we marked it as true. So once we are done with this, now we have to run a loop on starting from index 2, sorry, uh, starting from index 2 and forward, right? From here to we need to check if this guy is a palindrome. So how will we do that? I was just going through the explanation, and we'll see it together. Let's use a DP with dimension n to n. DP of I and j is a boolean representing if the substring is inclusive of ij is a palindrome. We initialize DP of I equal to true for the substring of length 1. That's what we did. And then DP of I plus 1 equals to S of I plus 1 for the substring of 2. We basically we are just checking if 0 and 1, like that's what we did, right? For length 2 we are doing this, and we are updating the DP table. Now we need to populate the table. We iterate over all ij pairs starting with pair that have a difference of 2 representing substring of length 3, then pair with difference of 3, then 4, and so on. For each ij pair we check the condition from earlier. S of I equal to S of j. So yeah, what we are doing here is we are checking the outermost element. If they are same, then we are checking the DP of it. So yeah, okay, I got it. Let's see, let's read on, and then we can see this condition in the diagram as well, in the matrix as well. Yeah. So if this condition is true, then the substring with inclusive bound ij must be a palindrome. We set DP of I and j equal to true because we are starting with the shortest substring and iterating toward the longest substring every time we find a new palindrome. It must be the longest one we have seen so far. We can use this fact to keep track of the answer on the fly. Yeah, true. So let's see the code. See, here they are traversing till n. They are traversing till n for I of I. So for length 1, here they are traversing n minus 1 because we will be doing I plus 1 here. So that is why they are doing this. And this is for string 2, and this is for length 2. This was for length 2, and this is for the whole string. So int difference is equal to 2. Okay, why are they using difference is less than n? I is equal to 0, j is equal to I plus diff. Why I don't understand why are they using the diff in a nested. So initialize n, okay, DP. So here they are creating DP answer is equal to this, will hold the inclusive bound, set all is equal to true, then iterate over I plus 1. Now we populate DP, iterate over diff from 2 until n. This variable represent difference j minus I. Okay, so difference is 2, which is I plus diff is j. So character of I and j should be equal. Okay, got it. So two, right? Okay, got it. And dp of and dp of I plus 1 and j minus 1 should be equal. Okay, I'm kind of getting it. So let's go back to this guy, and here we can see that um, that um, yeah. So we have populated the single and the character with two two elements, right? Two characters. Right now we need to traverse from the what do you say, ca- substring, which is of length 3, right? So how do we do that? So what they have done is they kind of started the difference is equal to 2, and to identify j they are adding I is equal to 0 plus 2. So I plus 2, I is 0. So j would be initially pointing here, and I would be pointing at 0. Okay, this guy. Okay, got it. So okay, I would be pointing here and j would be pointing here. So basically now they are targeting sorry, my bad. Now they are targeting the let me use a different, so now they are targeting this guy. So yeah, and they do I plus 1. So yeah, that's what they are doing, I plus 1 and j minus 1. By doing that, they I by doing I plus 1, they will come at this guy, and j minus 1, they will point at this guy. Basically they will point to this guy. So if this is true, then this all becomes true, and then they can put here true. So again, if we see now, we have to go to the next element, right? So I will increment, difference will be 2, then it would be this guy, right? They'll check for this guy. So I will be 1, and they are j j would be here. I plus difference would be 2. So I, let's say I is 1 plus 2 equals to 3. So j would be pointing here, and then they will minus it, and they'll come to, so 3 minus 1 is 2, and 1 2, so they will come to 2 and 2. So this will also become true. So once they are done with this, they will go here, and as they are not equal, this guy won't be considered. Then they will try this. This is also not equal. So yeah, we need to also insert false for such things. And then they will consider this. This will also not be considered. And then sorry, my bad. and then this guy would be taken, which will again not be considered, so everything will be false until this point. So all we are doing diagonally, we are filling up the cells uh, with respect to these sizes. So as the size increase, we start the a later cell, and as and when we encounter true, we update the count or answer. Hopefully that was helpful, and if at all you're having trouble understanding this, please watch Tecto's um, video on longest palindromic substring. This is quite helpful, and I believe that, like, this is quite a difficult problem for at least for me it was difficult to come up with a solution on the first go. If I wouldn't have seen this video, I wouldn't have understood it. So basically, let's see where is our stream, and I'll just reset my camera because after 30 minutes it dies. So it dies, I mean it shuts down. Hopefully the voice is better now. Okay, so yeah, first we gotta let we gotta create. First of all, let's break down how we'll be proceeding towards this. Let g let create a dp array, and let n is equal to s dot length, and we have to create an 2D array of n dot fill dot map, and a new array n, what's that, yeah, n into n, right? It's n into n, and dot, and I guess we don't have to fill it with anything right now, but yeah, we have created using this, we have created our 2D array. And then once we have done with this, then we can simply go to the for. Okay, so now what we can do is simply fill this first fill for the single characters. So for let I is equal to 0, I is less than n, I plus plus, where we will do dp of I equals to dp of I, we will insert true. Okay, and then we will do second, so fill dp for length 2 if both are equal. So what we gotta do here is let I is equal to 0, as we'll be incrementing this guy I by one character each time, so we have to do it for n minus 1. So if here what we'll do is if dp of I equals to dp of I plus 1. Hopefully I'm doing it right. Yeah, I plus 1. Yeah, if they are equal, then what do we do? And we have to also update our answer just in case if um, our string is not big enough. Then I also forgot to ask the interviewer, or we should have asked like what would be the length of the string. So s will be of length 1, right? So in that case, if s is of length 1, then we can keep our answer as 0 of 0. Okay, and let's jump back to, okay, sorry, my bad. Okay, yeah, we can then put dp of I So am I doing it right? I don't think so. I'm doing it the right way. So we want to compare 0 of 0 is equal to this guy, then 1 of 1 is equal to, okay, yeah. So yeah, I'm doing it right. So dp of I and I plus 1, we need to set it to true because dp of I we have already set it to true, but yeah, we have to do it this way. And then we will also update the answer I and answer of I plus 1, sorry, dp of 0 and then 1, then I plus 1. Or we would have straight away answer equals to 0 I comma I plus 1. We Okay, so once we have done with this, then can go to the next part where we iterate for length greater than equal to 3, right? So how do we do that? For let difference is equal to 2, so starting from 0, that's why 2, difference is less than n diff plus plus for let I equal to 0, I is less than n, I plus plus, then let j is equal to diff plus I will give us the j. And then the formula that we have to use is if actually here, what am I doing? S of I and S of I plus 1, we should have checked this instead of that, and then dp of I plus 1, we should have updated it. Okay, at this point I think that I am just mugging up the code, but I have to just trust the process of learning the DSA and this is the first time I'm dealing with the DP problem. So yeah, hopefully I'll get better at these. So j, if j is equal to 0, okay, so what we need to do is we need to check if I is equal to s of j, and the dp of I plus 1 is equal to dp of I plus 1 and j minus 1, uh, which will give us the middle element, is equal to true. Then we know that this is a palindrome, and then we can simply update dp of I and j to be true and update our answer with I and I plus 1, sorry, I and j. So once we have done with this, we can simply return s dot substring of answer of 0, answer of 1. Hopefully this is right. If I minimize this and run this, yeah, there are some errors. AB is the so let's see what console log, let's console log it. ANS, run this. What are we getting? 1 and 3, 0, 1, 1, 2, 3. So AB, should I do plus 1 to this guy? If I run this now, okay, yeah, it accepted now. And if I submit, okay, cool, it got submitted. Let's remove this, and so that why is the time complexity that bad? So time complexity of this would be O of n square, because yeah, O of n square, and the space complexity would be O of n square, because here we are just traversing through where n being the length of the length of this string, right? So of n square, yeah, we are iterating through a matrix, so we have to do it of n square. So here also of n square, we declare n into n table dp, which takes of n time. We then populate n square states time to compute, and space is also n square. Yeah, got it. Cool. So that's it, guys. This is pretty good question, and as Neetcode also said, it's a favorite question that Google likes to ask a lot of time. So yeah, in the next streaming, we'll try to solve the palindromic substring, and let's see if we can solve it. Okay, see you in the next stream.